in 2 minutes. Right. Just imagine with YouTube and lot of other social media platforms, anybody can become a celebrity, right? All of you sitting in room are, or who are online as well, though I can't see their faces, but are, have all the qualities to become a celebrity. All that you need to do is maybe have a channel of yours or do something. And people who are not able to do that, in order to feel like somebody who is seen by a lot of people, gets attention, people are giving money to see their names on the screen. Isn't that interesting? What makes people give money to just see their names on the screen? What is it? Is this some sort of behavior? Is this some sort of something which is in their mind, in their heart, but weren't studying here?
Feeling lonely.
Okay. Right. Don't look at this. This will work, right? Or I'll be using. Right. Right. Now, very quickly, till this point, whatever we have done, I'll repeat that. Okay, so that we are all on the same page. We started this particular course with basic understanding of mean, median, mode. Right. I'll not be talking about descriptive statistics, differential statistics. I'll only be talking about things that I will be using mostly in the class today. Though we'll be using everything, but then things that we'll definitely be touching on. Mean, median, mode, everybody is here about. Mean, everybody here about. What was the basic idea of studying statistics? The basic idea is that there is population out there. It becomes very, very difficult for us to go and collect data on the entire population. We can't collect data on the entire population. That is why we take a sample. And from that sample, we try and infer something about the population. We try and estimate the population parameter from the sample. This thing is okay with everybody? Now comes the important point of discussion where I say that, okay, let us talk about the weight of students in MU. Weight of students in MU. What all will be included in this population? Come on.
All the students.
Don't use your laptops for 2 minutes, okay? Don't use the laptops. This is a very important discussion that we are having. And people who are online also, my request is, please pay attention in today's class. Even if you have a very, very important work, keep it aside for 2 hours because this class will help you a lot in life. Not only for this course, but in life generally, I'm saying. Right? Because we'll be doing hypothesis testing from end to end, from basics to the last point. And if you don't pay attention today, it will be gone. And if you have not paid attention till this point, it is okay. This is a new topic and I want you to pay attention. Can I have your? Right. So what was let's say, and I want you to interact. I want to find out the mean weight of or average weight of MU students. What all will my population be consisting of?
Students.
All students?
Or faculty.
No. Ideally, only students weight in MU.
Ideally, all students, but
all students, as in from all the programs.
Yes.
The UG programs, the PG programs, PG Executive, Bharat, everything. Now, let's say if I tell you that there are 1200 students, there are more, but then let's say there are 1200 students. Should I go and collect data from each and every student? Too much? Yes, technically yes, but it will be too much of effort and all. What do? I take a few students from PGB Bharat, few students from RISE, few students from PSM, few students from UG BMT, PG BMT, and any other program that we are running. Financial markets, this, that, whatever. All the programs. I collect few students from all these programs. Let's say there are 10 programs running. I collect data from 5 students in each program. I get a sample of 50 students, right? Now I tell you, and this is very important. Now I tell you that I am 100% confident that the mean weight of MU students is ranging from 0 to 200 kgs. Am I correct?
Yes.
0 to 200, I'm 100% sure. Right? would you be happy about it? You would have done this without even collecting the sample. You won't think that I am a good person, good statistician who has done all this, collecting sample from 10 different programs, and then I come up with a statistic which is this way, right? But then my confidence level will be 100%. My confidence level is I am 100% sure, right? What will be better? Let's say if I do this and I tell you that this is ranging from 0 to 200. My friend also does the same. And he says that I am 100% sure that the weight of all the students in MU, or the mean weight, is between 30 to 110. Who's better? He's better because with the same level of confidence, the range is going down, right? Which will help me take decisions better, right? Now I say, let's say I have another friend who comes and says that, I am 100% sure that the weight is between 40 to 90. Even better, right? Even better. Then someone else comes and says that I am 95% sure that the weight in between 60 to 61.5. What have I lost? I've lost 5% confidence, but the range is very, very, very narrow now, right? In statistics, generally we say that it is not possible to say anything with 100% confidence. The very reason is, let's say there are 1200 students, but there is one student who is an outlier, infinite weight. Because of that person, the range might move anywhere, right? So we are never 100% sure. But what we have done in this process is, at 95%, right, the range is only 1.5, 60 to 61.5. At 100%, I was saying 0 to 200, right? So all of you are agreeing to this fact that we are okay with little bit, decrease in the confidence level, but we would want the range to be as small as possible. This is clear. Now, what all is this range dependent on? I showed you one thing, that the range is very much dependent on the confidence levels. The more the confidence, the broader the range, right? The more I want to be confident, I'll have to take a range which is broad. First thing. Second thing is, if I increase the sample size, I took 50 people. Instead of 50, if I take 500, I'll have a better estimate. I'll be more confident. And the range should also go down. If I take 1,000 students, even better. If I take all 1,200 students, I'll be 100% confident with exact number. Right? That's how it is. So as N is sample size. As the sample size is increasing, confidence is going up, range is coming down. All of you are agreeing to this, right? Now, this is the whole idea of studying statistics. Let's say you are planning to launch a new product in the market, right? For this product, you want to see what is the perception of people studying on, let's say I take the same example that I was talking about, that people these days are posting videos, doing live YouTube, whatever you call it, streaming or something, where they just put a QR code and people pay money for them to study, right? Now I want to find out whether this is better or writing names is better. There are two things. One model is where people are just studying and writing that help me study. Whether this is better versus somebody who's writing names and asking for money, that to see your name on the screen, give me money. Which is better? I ask people about their willingness to pay on a scale of 1 to 7. 1, I'll never pay for this. 7, I'll definitely pay for this. I take this and I take this, right? Let's say only 5 people have responded to my survey. And from these 5 people, I get that willingness to pay when somebody is studying is 4.5. And willingness to pay when somebody is writing names is, let's say, 4.8. Will I be very confident in saying that willingness to pay is always higher here? Because I just have 5 people. As N increases, I'll be able to say things more confidently. This is how it is used in testing things and all. This you can apply in any test. I have 2 advertisements for, let's say, Apple. I show one advertisement. I ask you that after watching this advertisement, what will be your perception for Apple? On a scale of 1 to 7, the perception is better than what it was before. It has gone down than what it was before. I show the second ad also. I ask the same question. If there are lesser number of people, I'll be less confident whether this is correct or not. Right? Correct? Now, in the previous classes, we talked about distributions. All of you are okay with distributions. I hope you've done the questions also on distributions. Now I'll introduce you to, all of you remember this particular thing that is there on the screen, central limit theorem, right? As the sample size is increasing, I wanted to see something here. As the sample size is increasing, the standard deviation has gone down, right? And because of that, I am having a large peak here, and I am able to say things with more confidence, right? What happens when standard deviation goes down? The instability in the data goes down. Standard deviation high, data is not stable. Standard deviation low, data is stable. Consistency in the data has gone up. When the data is more and more consistent, I'll be more and more confident. Let's say if I get to know that weight of all the students in MU is same, standard deviation is very, very low. Weight is same throughout. Consistent data, stable data, standard deviation is low. Then if I take sample of 5 students, I'll be able to very confidently tell exactly what will be the mean weight because there is no variability in the data. Am I making sense? Right. Now we'll be using these concepts. If the idea is clear, we'll be using this confidence to define something today. Right. Did we discuss about normal distribution? We discussed about standard normal distribution. What is the standard normal distribution? Yes.
Mean is 0 and standard deviation is 1.
Standard normal distribution is a special case of normal distribution where I know that mean mu is 0 and standard deviation sigma is 1. We also calculated the z value. Remember standardized formula that we used? Z is nothing but x minus mu upon sigma. This we have already done. Right? We did central limit theorem as well, where we said that irrespective of where you are drawing data from, whether the distribution that you are drawing data from is binomial, Poisson, or any other distribution, the sample mean will always follow a normal distribution. We did an example of dice also, right? Now I'm using all this. And from now onwards, whenever I tell you that I am, working on a sample data, there should not be any question that why are you taking normal distribution? Because sample data and the sample means will always follow normal distribution. This is a fact. Did we saw these things on Excel as well, right? Standardized function and normal distribution, norm.dist, we have done that. Wonderful. Now, let us say that we start collecting samples. I am giving you an application of CLT only here, where I have, let's say, 4 people, and these 4 people have an age of 18, 20, 22, and 24. 18, 20, 22, 24 साल के 4 लोग हैं मेरे पास. What is the probability of selecting somebody with age 20? 1 by 4. 0.25. What is the probability of selecting somebody with age 18? So the probabilities remain the same. You are saying that it is equal, which is 1 by 4 in all the cases. Right? Equal. Now I am doing sampling. Now in the sampling, what I do is I am selecting 2 people randomly. Out of these 4 people, let's say 1, 2, 3, and 4. 18, 20, 24, 18, 20, 22, 24. Right? I want to select 2 people. What is the possibility? I can have 18 in the first observation, and this is with repetition. Okay, I am putting the person back. So I can select 18 both the times. I can select 18 once and then 20 once. 18 and 22, 18 and 24, 20, 18, 20, 20, 20, 22, 20, 24. Possible? I'm selecting it. I'm selecting the person twice. Right? Now if you find out the mean of these 2, what will be the mean?
18.
Mean?
19. 20. 21. 90, 20,
21, 22, 20, 21, 22, 23, right? 21, 22, 20, 24. These are the means that we are getting. Now you tell me, what is the probability of getting somebody, or what is the probability of getting a sample with mean 18?
By 16.
1 by 16, right? Similarly, for 24 also it is 1 by 16. But for 19, it is 2 by 16. For 20, it is 3 by 16. For 21, it is 4 by 16. Then again 3 by 16, then again 2 by 16. Earlier it was same for all. Now it is not same. Now it is lesser for 18, going up till 21 and then coming down to 24. Right? And the highest is for the mean. This has started looking more like a normal distribution. CLT, central limit theorem, we did the same example using dice. You are rolling a dice 1, 1, 1, 2, and now with this, I understand one thing, that the mean, and I want you to focus, okay? 18, 20, 24, 22. The mean was 21 and the standard deviation was 2.2. Right? Earlier when I had only these 4 people and I was selecting one person randomly, the mean was 21 and the standard deviation was 2.2. Now what has happened is that the mean is remaining the same with this particular thing. The mean is remaining the same, but the standard deviation has gone down. Why? Anyone? Because the variability in the data was higher earlier. All were having equal probabilities. The chances of selecting on extremes was equal to the chance of selecting somebody from the middle. Now the variability has gone down because the chance of selecting on the extreme is lower than the chance of somebody getting selected from the middle. That is why the standard deviation will obviously come down, because now it is not, the variability has gone down. I'm not selecting more values from the extreme. The standard deviation of the sample has now become 1.5. Mean has remained the same. So if I write it like this, where I say that if there is a population and if there is a sample, population mean is mu, sample mean I'm saying x bar, right? These will be equal. If population standard deviation was sigma and the sample standard deviation is, let's say, sigma x bar, there should be a relationship between these two. What is this relationship? The relationship is simple, that x mu x bar is nothing but sigma upon root n. N is the sample size that you have. So in this case, the sample size was 2. I was selecting 2 people, right? From this to this, when we started selecting 2 people from this particular population only, I saw that the mean is remaining the same. The standard deviation has gone down to 1.58, and the formula that I apply and I get the same value is this. Are we okay with this? Why is the standard deviation going down? Because the variability is going down. Variability will go down with respect to the n. As the sample size will increase, if I would have taken 4, n as 4, the chance of selecting somebody with 18, 18, 18, 18 would have been even lower, because there was only one case now out of, right? Now, if this is clear, I want you to please write this somewhere. I was telling the participants today, and this is for people who are online as well. Please, this is the request, please have a piece of paper or make notes somewhere. And whatever I am asking you to write, please write today and keep it with you. Keep looking at it, because this will help you. So first thing that you'll be writing is like this, just like what I wrote. On the top, right? Small, very small, okay, population sample. Draw a line, population mean is mu, sample mean is x bar. Population mean is sigma, sample mean is sigma x bar, which is nothing but sigma upon root n. Don't write this mu x bar, okay? Don't write this. This is, you should not see this. Write it like x bar only. Write x bar only. Okay, are we good? May I move forward? Shall we? Okay, wonderful. Now the formula for Z. Do you remember the formula for Z? Z formula earlier was what?
X minus mu by
X minus mu upon sigma. Now my formula for Z when it is sample. So this was for population. So right below what you wrote, you write Z is equals to X minus mu upon sigma. Now Z value for sample will become what? X minus X bar upon sigma by root n. Right? Now let us do a question. Would you be interested in doing the question? Okay, before I move to the question, let me introduce one more concept, okay? And I want you to listen to me very carefully. Whenever I say, now let's say we are doing the same case that we were looking at, the mean age of MU, right? Mean age of MU. Would you mind coming here so that I don't have to? So I'm talking about mean age of MU. I've collected a sample of 50 students and the mean age that I have got is, let's say, 20. Mean age that I've got is 20. And I say that I'm 95% confident that mean age, so this is from the sample, and I'm saying that I'm 95% confident that the mean age of MU is equals to 20. So this is my X bar. All of you are understanding this is from the sample. Whatever I get from the sample will be termed as X bar. So mean age of sample, X bar is 20. And I am saying that I'm 95% confident that the mean age of MU, of population mu, is 20. What does this 95% mean? It is very, very important to understand this 95%. I will tell this to you in two ways. वो कहानी है, कान ऐसे पकड़ो या फिर ऐसे पकड़ो, whatever. कान ऐसे पकड़ना, कान ही पकड़ना. That is the same thing with this 95%. What are the two ways? When I say that my sample mean is 20 and I'm 95% confident that the mean of population is also 20, I am saying if you will draw samples from this population, अब मैंने सैंपल 50 का कैसे भी लिया वो मेरी इच्छा है, अब आप करेंगे तो आप अलग तरीके से सैंपल लेंगे. You will be drawing sample is random. The 50 people that I got will be different from the 50 people that each of you will be getting if you do the same thing. But what we'll observe is that 95% of the time, so if 100 people are doing it, or if I am drawing 100 different samples, right? These samples will be very close to this. Very close to this. Another way of saying it, and now I want you to again pay attention. And this is very, very important. Now what happens is, this is our normal distribution. What am I saying? My X bar value is 20, right? Now, I also tell you that in a normal distribution, the total area covered under this is what? Total area covered is 1. You all are agreeing? As we move on this side, it starts from 0 and goes up to 1. If I talk about 95% area being covered, that means this area, entire thing. So this area is 95%, means what is remaining? 5% is remaining, right? Or this is 0.95 and this is 0.05, right? I can find out the Z value at this particular point. Can I? Yes or no?
Yes.
How do we find out Z value at this particular point? We will be looking at a table. We will be looking at a table. Where do I get that table? How do I just say okay? Don't show this again. Right? I say that this is a Z table. This is a Z table. I want to find out the value of Z when the area covered is 95%, 0.95. Help me find out where is 0.95.
1.6.
0.94, 0.95, so it should be in between these two. Let's go on this side. This is where I am covering 95. 0.9505 is 95. 1.60, 2, 3, 4, 5. 1.65. So all of you can very clearly tell me that this is 1.65. Right? Now, I am saying that I want to be 95% confident that this area, or 95% confident that my mean is around this only. What does it mean that, or what it means that it means that the mean means that the mean I've done something. What you're saying is, if this is 20, and if you are drawing samples randomly, or if I draw 100 samples, I will have the value in between 95% area. It can be on the higher side or the lower side. So this area, for me, should be 95. अगर मैं ये बोल रहा हूं, if I am saying that the mean is 20 and I'm 95% confident, that means that it will never go below this particular point and never go above this particular point. I am 95% confident. So this area should be 95. Now in order to find this D and this D, what should I do? I can find out whatever is remaining area, what is, if I'm covering 95, what is remaining outside? 0.5. But then this 0.5 is now divided on two sides, and we all know that it is a symmetric curve, so it should be equal on both the sides. So how much should be there on both the sides? 0.025 on this side and 0.025 on this side. Can you find out? And if this is 0.025, what is the area on this side completely? How do we find this? All of you remember how do we find this? We find Z value, thinking that this is the entire thing that I'm covering, this also. And then I find out this Z value. And then I subtract this from this, right? That's how I find it out, right? So what will this value? This will be, if the remaining area on this side is 0.025, what will be covered? 0.975. So this Z value will be in the table at 0.975. Are you all with me on this?
Yes.
So let us see, where do I find 0.975? I know, I will not go back to the table. You know how to see the table. I know the value is 1.96. Okay, let us use a clean page. I am doing it again for those of you who could not follow. I want to find out the 95% confidence interval. What is confidence interval? If I am saying that I am 95% confident, that means that the mean should not go below this or above this. Right? In order to find this out, what will I do? I say that this area that is being covered is 95. Or 0.95. If this area is 0.95, together, this and this should be 0.05. That means this is 0.025 and this is also 0.025. Now I want to find out this Z value and this Z value. This Z value is simple. I can directly find out the Z value at 0.025, which will be negative 1.96. And this value will be Z is equals to positive 1.96. This is till this point we are okay. Now I can find out the associated value of X also. I can find out the associated value of X also. How do I find out the associated value of X? What was the formula that we were using? Remember this formula? Right? If this would have been a population, not a sample, population. In population, how do we find out this formula only? Z is equals to X minus mu by sigma. Right? I want to find out the X value. How do I find out X value? Z is, I know 1.96. 1.96 equals to X minus, what is mu? 20. Let's say I'm telling you that the sigma value is 2, or let's say 4. Right? So I say that this is 4. 4 into 1.96, whatever it is. What is it?
7.84. 7.84.
7.8?
4.
4 units. X minus 20. X will be 27.84. So I know that the higher range is 27.84. Similarly, I can find out the lower value also. which will be 20 minus 7.84, which will be 12 point something.
12.16.
So I know I'm 95% confident that my
Mean is between.
mean is in between 12 to 27.8, 12 point something to 27 point something. Now, that means that if I do it 100 times, if I am collecting sample from MU students 100 times, 95% of the times, the mean will be between this and this. There is a 5% chance that it might go outside as well. If 100 of us are doing it, for 95 of us, we'll be having the mean between this to this. That's what confidence interval means. Right? Now let us look at it in the form of formula. Again, so sorry. Here I just use the formula for population. If this is for sample, what do? I only make one change. Let's have collected sample from 16 students. So I just put under root 16, which is 4. 4 and 4 gets cancelled, and then the range will become 21.96 to whatever, 20 minus 1.96. Right? Let us see a few examples and let us look at the formula.
Sample के लिए क्या?
Sample के लिए the only difference is that you in the formula, this formula we don't use, right? The formula that we use for sample is by root n. That's it.
So, sir, the sample has a much smaller range.
Oh yes.
I would have thought.
Depends completely on the n value. Depends completely on the n value. Why is it smaller? Because I told you, and we looked at the example where you saw that if you're drawing samples from a population, the sample means will follow a normal distribution. And when you're talking about sample means, the variability is going down, right? That is why, because of the variability going down, the range will also come down. That is why samples are helpful, useful. I want you to read this. Can you read this? Readable, right? Find a symmetrically distributed interval around mu that will include 95% of the sample means when mu is 368 and sigma is 15 and n is 25. Right? What are we saying? I want you to visualize this in a way. Visualize it. This is the same example that you were looking at, right? Mu is 368. What you're told is that you have to find 95% confidence interval around this. When you know that mean is 368, then you know that sigma is 50, right? Now, if we have sample size is also told to you, which is 25. I'm using the same formula that we were using. The only difference in this formula, what you see here, don't be worried about it. Why? Because this is the same thing that we were looking at, just a different version of it. Let me show you how. D is equals to x bar minus mu or sigma by root n. Right? This is the formula. I take this here. This becomes the sigma by root n is equals to x bar minus mu. Right? Yes or no? Right? And then what do I get? If this gets on this side, this will become mu plus the sigma by root n. Right? If I am writing in terms of, if I'm writing this in terms of sample, I should not write like x bar. I should write x minus x bar. How do I erase this? Right. So I should write x minus x bar. Right. And this will be x bar here also. And this will also be x bar. So the formula that we are getting for x will be x bar plus the sigma by root n. Now, when the value of z is positive, which means on this side, it will be positive. In this side, it will be negative. So, I am using both in the same formula, which will be x plus minus z sigma by root n. Another thing, which is very, very important, please pay attention again. And this will be a rule, and this will be a rule, this will be a formula, a way to remember, and you also write it in your sheet, which is, if I'm talking about 95% confidence level, now I'm talking about 95% confidence, I can calculate one value, which is whatever is remaining outside. What was remaining outside? 0.055%, which is 100 minus confidence. Whatever is remaining outside is 100 minus confidence. I start calling this thing as alpha. Alpha is nothing but
Level.
a level of confidence which is related to the confidence level that you had. Now, if this entire thing is alpha, which is 5%, what is on one side? Which is alpha by 2. Alpha by 2, right? And the z value that you were calculating was at this alpha by 2. So I'm just writing this small alpha by 2 here to tell you that the z value that you are calculating is at alpha by 2. And that will give you the formula for calculating the interval. X bar, please write this formula. X bar plus minus d alpha by 2 sigma by root n. What is this formula for? This formula is for calculating any x value, which is upper bound and lower bound. So upper bound will be what? Upper bound will be the positive sign only, and lower bound will be the negative sign. Let's go to do an example.
1 second.
If there's any doubt, please ask me. And also write these, okay? X bar is the point estimate, which is sample mean. Where alpha by 2 is the normal distribution critical value at probability of alpha by 2 in each tail. Sigma by root n is also known as standard error, which is related to the sigma value. Or if you want to write it, there's one more way of writing it, which is x bar plus minus z alpha by 2 sigma x bar, where sigma x bar is nothing but sigma by 2. Now, if the question is where will we be using it, we'll not be using it. We don't solve it also, we'll get it from the Excel directly. But I wanted you to know how it is coming and where is it coming. So if this is clear, let's do one example quickly. What is the base for hypothesis testing, and that is why we are doing it also. Okay. May I? Now, this is exactly what we were making and describing and talking about. If you're talking about 95%, this is 95%. Whatever remaining is 5%. 5% divided by 2 is 0.0251 on both these sides. And we find out the z value here at 0.025, which is negative 1.96. And on the positive side, it is 1.96. Right? Lower confidence limit, upper confidence limit. Fine? Now, what is the meaning of this? If I am doing this 100 times, 95% of the times, the sample means, these are all sample means, x1, x2. First time when I draw the sample, second time when I draw the sample, and so on. 95% of the times it will be in this range only. Only 5% of the times it will be going beyond this range. That is exactly what we were discussing. Look at this example and please solve this for me. A sample of 11 circuits from a large normal population has a mean resistance of 2.20. This can be from any business, need not be from a manufacturing business. This can be from a space business, from any other business. Where let's say I tell you that I sample 50 people and I see that the mean time that they waited for their coffee in the restaurant was 5 minutes. What will be the confidence level, or what will be the interval where? So you can tell that on an average, people in my premise will be waiting for lowest this and highest this 95% of the times. Similarly, here we have a sample of 11 circuits from a large normal population, which has a mean resistance of 2.20 ohms. We know from the past testing that the population standard deviation is 0.35 ohms. Now, what all is given? Let us write the given information. What is n value? 11. What is the sample mean? 2.20. What is the standard deviation of the population? Sigma.
0.35.
0.35. You want to determine 95% confidence level. I can simply use the formula. Lower bound and upper bound will be x bar plus minus z alpha by 2 sigma by root n. X bar is given to me, which is 2.20. 2.20. plus I know at 95% confidence level, Z alpha by 2 is what? 1.96? 196. And then 0.35 divided by root 11. We solve this and we get the answer. Shall we? Right? Solve this and you get the answer where you say that this is the 95% confidence interval, that the mean resistance will be in between 1.99 to 2.4. The mean resistance will be, I'm 95% confident that the mean resistance in between this and this. Logically, practically, is it making sense? Why are we doing this? What do we get from this? So if I am in the manufacturing unit, I know that if I'm getting an order, where let's say the manufacturer has told me that I am allowing you a tolerance of 1.7 to let's say 2. My process is now not capable of doing it, right? In order to make my process capable, I'll have to make changes. But right now, my process is capable of producing the circuits which have a mean resistance of 1.9 to 2.4. Now, in real life, what happens is, in this case, if you would have observed, you were told the population standard deviation. Now, how do you find out population standard deviation? For finding out population standard deviation, you'll have to have data for the entire population. If I'm already aware of the population standard deviation of MU students, in order to find out the population standard deviation, I should have the entire population data. अब अगर पूरा population का data है तो फिर आप नाटक क्या कर रहे हो? You already have everything. You can just, if you know the standard deviation, why can't you know the mean? Right? In real life, we generally do not have the population standard deviation. If you don't have the population standard deviation, then this will go for a toss. This will go for a toss. Right? In order to take care of this, and in order to solve problems where population standard deviation is not given, we use another kind of table, which is known as a T table. So this is when we were using a Z table, and we'll be using a T table. Nothing changes. Only two things will change. Instead of Z, we'll be using T, and instead of this population standard deviation, we'll be using S, which is the sample standard deviation. I want you to look at this formula and write this also in your sheet. This is the case when, and please write, when population standard deviation is unknown, when sigma is unknown. Sigma is what? Population standard deviation is unknown. Population standard deviation is unknown. Right? This is the first condition of using T. Also, we say that T tests can be used for N which is lower than 30. Right? If the population is normally distributed.
S is sample standard.
Yes, S here is the sample standard deviation. This is sample standard deviation. And T is the value that you are getting from T table. I will tell you how to read T table also. After this was the boring part of the class. After this, the real fun starts when we'll start using it in practical scenarios. See, to use things in practical scenario, we need to know how things work. If you're using a pen, right? Using pen is one thing, but then you should know what all is there inside the pen. Then only you will be able to tell if the pen is not working fine, what is the problem with the pen. Right? So this was more to understand how things work, and then we'll get to very interesting stuff. After this, I'll give you a break for 5 minutes. I'll let you guys freshen up your mind, and then we'll start with the real fun. But this is more to know things, and then we'll be doing it on Excel also, right? So you don't have to worry about the calculations and all. I can show you the T table if you want to look at the T table, or I can just skip it also. I think you should know. कल को बाहर जाके मेरी बेइज्जती ना हो कोई तुम्हें बोले टी टेबल देखिए तुम बोलो ना.
Sir, it doubt this. So earlier when you showed us how we derived the standard deviation for the sample through the standard deviation for the population, you showed that it was basically the standard deviation of population divided by root of n. And that is what we just continued over here. And right now, what we are also using is the same thing. So,
Wonderful. That was an estimate. That was an estimate where we were saying that the sample standard deviation or the standard deviation that we are using is from the population only, dependent on the population. The idea is that if the population has certain standard deviation, the sample should also follow something similar, and as n increases, it will keep on going down. Here we are saying that you have no idea what the population is like. You don't know what the population is like. So you have become independent from the past. Past is, you don't have any bearing from the population. I've just got data, and this is what happens in real life. You get some data, you are collecting, let's say you want to do a market survey on the use of mobile phones, right? And you want to see how much people are ready to spend for buying a smartphone in a particular segment, let's say budget segment. अब अगर मैं आपको ये बता दूं कि in a budget segment the mean money or the average money that people spend is, let's say, 9,500 with a population standard deviation of 500, तो ये तो पॉसिबल ही नहीं है, क्योंकि पूरा पॉपुलेशन का डेटा आएगा तो ये तो पॉसिबल है. तो रियल लाइफ में क्या होएगा, आप बोलोगे कि भैया मैंने इन 500 लोगों से डेटा ले लिया, and from these 500 people what is the standard deviation? S. I will use this S. I don't know what is there in the population, right? In manufacturing, I'll tell you where is it. So does it mean that Z table becomes absolutely useless? No, no, no. In manufacturing, I have a friend, let's say I worked in Ashok Leland, right? There they make buses. I told you guys one bus takes only 8 minutes something to get assembled, right? Now, I know from the past data that there is a standard deviation in the time that is taken to manufacture these buses. That I can use. But if I don't have that past data, manufacturing में क्या होता है कि manufacturing an ongoing process. You keep getting data. In service premises also, it's an ongoing process. You keep getting data. From there, you can find out the population standard deviation. पिछले एक साल में जो हो रहा है उससे ज़्यादा क्या होगा population. But when you're doing market surveys, when you're doing research from people where you don't have past data, then this works, and this works generally better. This can work for both. This can work for the other case also in manufacturing or services also. T can work, right? Okay, let us very quickly look at T table and then we'll take a break. Okay, what does the T table look like? All of you remember one concept, degrees of freedom, where we discussed that, let's say if I am giving you 5, sample size is 5, and I want the statistic to be the same, I will give you only a freedom of choosing 4. 1 I will put from my side. I discussed this in the class, right?
sample.
Sample minus n minus 1 is the degrees of freedom, right? Now we'll be using that concept in the T table. Now see this. This is what a T table looks like. In the T table, in the first column, you have degrees of freedom. What is this degrees of freedom? N minus 1. So in the previous case, when you're talking about 11 circuits being produced, degrees of freedom will be 10. 11 minus 1. So you know that what row you have to do? 10th row. Then you know that, okay, my diagram looks like this. I can't draw here. Let me see if I can draw. I can. My laptop is also not working. It's okay, it's okay. Let me. इधर एक तो draw कर ही सकते. Just for this one. Now you know that this is the case. For 95% confidence interval, you are telling me that this is 95. Whatever is remaining outside is 0.025 here and 0.025 here. In one tail, how much am I having? 0.025. In two tails together, how much am I having? 0.05. That is exactly what you see here. So if I am talking about one tail, in one tail, what am I having? 95% confidence interval. In one tail, I am having 0.025. In both the tails together, I am having 0.0. That's it. That's it. Then I see, okay, I am talking about 95% confidence interval. 10 was the degrees of freedom. 2.228 is the E alpha by 2L. Simple. That's how you read a T table. That's how change it. How do I? I'm so sorry. I will have to learn all this. Right? So degrees of freedom is clear. How do we read a T table is clear. A very simple example we'll look at very quickly. A random sample of N25 has. I am so sorry. X bar 50 and S of A. What is this S? Sample standard deviation of A form a 95% confidence interval. How will you form a 95% confidence interval? You know degrees of freedom is N minus 1, 25 minus 1, 24. We will go to the table where we see degrees of freedom 24 in that particular thing. We'll go towards this side and we'll keep going till we find single tail 0.025. The value, let's say, is 2.0. You take that value, put it in the formula. X bar is 50, right? And then you need to have T alpha by 2, you've calculated from the table. You put that. You know, S value is 8 divided by root n. Whatever confidence interval you will get, that will be the confidence. Yes, sir.
Does the T table go on till infinity then?
Oh, yes. And there's and thank you so much for asking this, because there's a very interesting observation in T table, which is as n becomes large, you will have T tables which will go till ... infinity also. As n becomes large, right? N is the sample size. T table starts approaching Z table. The values in T table and Z table become almost equal. क्यों? क्योंकि जब sample size बड़ा होता जाएगा जैसे the sample standard deviation will start approaching towards population standard deviation. S will start becoming close to the sigma value, and that is how T starts approaching Z. Now with this we'll stop and I will give you a break, and then we'll move to something which is very important, which is your hypothesis testing. I want you all to be fresh and at the best of your attention when you come back. We have one more hour. I have only one request. Please come back soon.
Changed X bar and a bit interchangeable.
It is not. Shall we start? Everything back? Why is the class little heavy on this side? मुझे ऐसा लग रहा है center of gravity is. Okay. Let us. Okay. Next, we don't have a lot of time. What do they have after this? कितने बजे?
ले लो अरे ठीक कह रहे हो
Let us.
आज 1:30 बजे से है समझ आज 18
चलिए.
वो बंदा जो 11 तारीख को
Now, guys, we will be talking about hypothesis, formation of hypothesis, why hypotheses are written in a specific way, how do we test it, why do we test it, and each and everything possible about hypothesis in the next 1 hour, almost. Okay, what is the definition of hypothesis? ये तुमने करी हुई है. What is the hypothesis? Any statement that can be tested. बहुत ध्यान से सुनना है. Any statement that can be tested is a hypothesis. Statements which have a claim but not testable are propositions. Proposition और hypothesis में फर्क है. Propositions are claims, statements that are claims but may not be testable. Hypothesis has an element which clearly says that it is a statement which is testable. Now, a testable statement can be qualitative, can be quantitative. For example, I tell you that all the swans are white. right? All the swans in this world are white. Now, please pay attention to the words. All swans are white is what I am claiming. I claim that all swans are white. This is my hypothesis that all swans are white. Now, in order to prove that all swans are white, I bring 5 swans in the class and I show you that see, these swans are white, which means all swans are white. Will you believe me? No. You will not. You will tell me, okay, your statement was all swans are white. You have brought 5 swans. All of these are white. We are not rejecting your claim. तो आपने बोला हम ये नहीं कह रहे हैं कि आप झूठ बोलते हैं. We are not rejecting your claim, but we can't accept it also. If you accept my claim, then you are accepting that all swans are white only on the basis of this small 5 sample. Right? I bring 1,000 swans. Will you then believe my claim? No. Or you will still say, क्या हो गया 1000 ले आए तो और भी होंगी. I bring 1 lakh swans. Now, let's say there are only 10 lakh swans in the entire world. And I bring, out of those 10 lakhs, I bring 9,99,900 swans and all are white. Will you then believe my claim?
90%.
No. आप सोचिए कि आप क्या कर रहे हैं मेरे साथ. मेरा पूरा जीवन निकल गया है swans collect करने में. And you are still telling me that all swans are not white. बोले अभिषेक वशिष्ठ, what you are saying is fine. We are not rejecting your claim. You are saying all swans are white. We say that, okay, do not reject this claim. Do not reject. But I will not say accept this. Correct? Now, he brings 1 black swan. Only one. As soon as I say that all swans are white, he says, I have a swan at home. It is black. He brings that swan. What will you tell now? Reject my claim that all swans are white. As soon as he brings 1 black swan, my claim gets rejected. Right? Do you understand what is happening? If I have made a claim, I can bring as many evidences as possible. You will only say that do not reject. Do not reject, do not reject, do not reject. You are never saying accept. As soon as he brings one counter-intuitive or counter evidence, you are 100% confident saying reject this claim. Let's take one more example and then we'll bring it to business. Whenever there is a court case on anyone, what is the starting assumption?
Not guilty.
Not guilty. Innocent until proven guilty. Innocent until proven guilty. Right? Now the onus is on the other side to prove that the person is guilty. If they are not able to prove it, the person remains innocent. Now if I am, let's say my friend Gaurav has committed a crime. क्या crime करना चाहिए? Robbery. He has committed a robbery. Right? I am defendant. I am defending him. Right? He is the judge. I bring him evidence and I tell him, see, my friend has not committed this robbery. The police could not find any fingerprints, this and that. He says, okay. Innocent. I am not saying that he is guilty. The assumption right now is that he is innocent. Because that's how he started. But then he brings one evidence where there's a video of him stealing. What will the judge say? I brought 20, 30, 40 evidences. मेरा दोस्त तो उस दिन शहर में ही नहीं था. ये तो रॉबरी कर ही नहीं सकता, इसके हाथ ही नहीं है. But he brings one video. He brings one video and it is done. Getting what I'm trying to say. One count evidence, one thing. Oh, you are telling me, I tell you, the mean age of MU is 20. I am bringing you samples on samples. See first sample. And when I'm saying 20, I'm saying in a range from 19 to 21. 95% confidence that it is 19 to 21. 19 से 21 है देखो एक सैंपल 19.3, 19.8, 19.4, 19.1, 20.1, 20, 20, 21, 1. Then he comes and says it's 36. Right? Are you getting what I'm trying to say here? First thing. Second thing is
36 से mean थोड़ा disturb हुआ 36 से mean थोड़ी disturb हुआ
नहीं उसने बता दिया कि मेरा आपके कॉन्फिडेंस लेवल से बहुत बाहर आ रहा है मतलब ये ब्लैक स्वॉन आ गया तो ब्लैक स्वॉन आते ही तो मेरे तो व्हाइट स्वॉन सारे में 50 सैंपल लेके आया है भाई एक लेके आया एंड वी आर गॉन राइट नाउ दिस इज ऑल दी स्टेटमेंट्स दैट वी टॉक्ड अबाउट आर टेस्टेबल एंड देयरफॉर दे आर hypothesis. There are two kinds of hypothesis. One is a null hypothesis. The other one is an alternate hypothesis. Null hypothesis is the by default hypothesis. The claim that has been made. All swans are white. Null hypothesis. Right. Alternate hypothesis will be swans are not white. All swans are not white. All are not white. Let us talk about a few business cases. Pepsi says that we have 300 ml of cold drink in our bottle. Right? We have 300 ml of cold drink in our bottle. Now you bring evidences. Pepsi says that, okay, have these 100 bottles and do a sample of 2 each. Right? You take 2 bottles, find out the mean, 2 bottles, find out the mean. 50 such samples you'll have. You find out in all these 50 samples that it is in the confidence interval that you mentioned. But then there's one bottle which is empty. Pepsi will go for a toss. Yes or no? Right? Null hypothesis. Null hypothesis is a hypothesis which is the claim. Now you will read this in many books. You will read this in many books. That null hypothesis is the hypothesis which is the claim made by a researcher also you will read. Oh my God. Claim made by researcher is null hypothesis. Claims made by companies is alternate hypothesis. You'll read all these kind of bhatkau statements in the books. Don't read book on this. I generally ask students to read books. Don't read books on this. Remember what I say and remember it exactly in the way I say. What are the possibilities in this world? Let us think about Pepsi example only and let us talk about the possibilities in which Pepsi can talk about its 300 ml bottle. Pepsi says, now you tell me logically, Pepsi क्या बोलेगा? My bottle has exactly 300 ml of cold drink. Not possible. Not possible. So they'll say that all my bottles have more than 300 and understand it from the business point of view. If Pepsi says that, if you are paying for 300 ml, you are paying for 300 ml. If you receive less than 300 ml, you have all the right to sue Pepsi. आप तो चले जाओगे कोर्ट. Pepsi तो नहीं चाहता है कि उस पे कोर्ट केस हो. Pepsi will make sure that it is at least 300, which means 300 or more. At least 300 is 300 or more. But there's a cost implication. In order to be safe, Pepsi starts filling 350, 320. Cost 20 ml के पैसे थोड़ी ना दे रहे हो आप. तो 50 ml एक्स्ट्रा डाला Pepsi ने, उसके पैसे तो आप दे ही नहीं रहे हो. So Pepsi would want to keep it as low as possible, but also make sure that it is above 300. But what Pepsi is saying is that the cold drink, average cold drink in our bottles, mu, is greater than or equal to 300. Exactly this is what they're saying. Yes or no? Pepsi. Then let us say that there is a bag manufacturer. Bag or chair or table. Which one do you want? Bag, chair, table. Bag. Mokobara. Right? Now, Mokobara, you know the model? Do they manufacture? Now I don't know, but initially were they manufacturing?
not even now
Not even now. They were getting it from some other country. Right? They were getting it from some other country. Now, whosoever is their distributor or whosoever is their manufacturer there will tell them that there are these 20 things that can go wrong in a bag. What are the 20 things that can go wrong in a bag? Quality check, quality inspection. All of you would have seen. There's a list. Quality okay, certified. Then there's a stamp also. Quality checked. There's a tick mark. You would have seen all those things, right? How do they do it? There's a quality inspection which is done pre-delivery. In your cars also, there's a pre-delivery quality inspection when you receive the car. Before you receive the car, they call it pre-delivery inspection, PDI they call it. Where the salesperson will check your car thoroughly and see if there's any problem. There have been cases where the car company forgot, the showroom forgot to put in the oil, the engine seized. It's a cost for them. They would never want to do it. So there is a quality inspection that gets done. So let's say in the Mokobara, this is not a Mokobara bag, okay? I'm just giving you a name. So in the Mokobara bag, they do a quality inspection where they say there are 20 checks that we do, right? And because of the pressure in the market and all, they say that okay, the number of defects should be less than or equal to 2, or should be less than if there are more than 2 defects. We call the piece defective. There is a difference between defect and defective, right? Number of defects are possible. Defective is one. The item gets defective. In the defective item, you might have multiple defects. ये समझ में आ रहा है जी? Now I'm talking about defects, and let's say the company has decided that if there are more than 2 defects, not the major defects, but if there are, we are talking about small defects. For example, thread coming out from somewhere, right? The chain maybe not working properly. Maybe the is a little dirty. The packaging is a little torn. These kind of defects I'm talking about. And Mokobara has told the manufacturer that if there are more than 2 defects, we will reject the bag. How will you write it? The number of defects should be
Less than
less than or equal to 2. So you are saying that mu, average number of defects, should be less than or equal to 2. Moko. Then there is a third case where, let's say you're talking about a car manufacturer. The car manufacturer says that we give a warranty on our engine for 1 lakh, 3 lakh. There are different cars. Toyota and all gives it for 3 lakhs. Maruti and all give it for 1 lakh, I guess. Right. Now the car says that we are sure that the engine will run for exactly, and they have these things for a lot of things, brakes, clutch pads, this, that and all. It'll run for exactly. I recently got my car serviced, the other one, where they told me that there is a steering assembly something, and it gets faulty after 1,20,000 kilometers. Come about me. So it gets faulty at exactly, or at exactly a certain point, your car will start showing you a sign. For example, in my car, it starts a signal for getting the car serviced at 10,000. Exactly at 10,000, it will tell you service, right? The car starts beeping exactly at 80 speed once. It beeps once and then it keeps on beeping after 120. Exactly at a certain thing. So let's say your car will ask for service exactly at 10,000 kilometers. Exactly at 10,000 kilometers. Right? These are the 3 statements that are written here. And all 3 are null hypothesis. Now the question is, what is a null hypothesis? Any statement that is testable and consists of an equal to sign is your null hypothesis. You will not find this definition anywhere in any of the books. Forget all the other definitions, claims, this, that. No. All are confusing. The easiest and the best definition is a null hypothesis is the hypothesis which has equal to sign in it. This equal to sign can be lesser than equal to, can be greater than equal to, or equal to. All 3 are possible. The example that you are seeing right now on the screen, mu is greater than equal to 300, null. Mu is less than or equal to 2, null. Mu is exactly equals to 10,000, null. Now if this is the null, where Pepsi says that the cold drink in our bottles is at least 300 or more. What is the opposite of it? When I said all swans are white, the opposite thing was all swans are not white. So what will be opposite of 300 or more? Less than. So mu less than 300 is the opposite thing. When Mukobara is saying that we'll reject the bag if there are more than 2 defects. What is the opposite of it? We'll accept the bag when it is less than 2. Right? Mu should be
More than 2.
Yeah. If it is more than 2, they'll be rejecting it. What will be opposite of this? Mu is not equals to 10,000. Now, the hypotheses are like husband and wife. They don't like each other, but they come in pair. Right? So, don't like each other, they're opposite of each other. Or maybe siblings, opposite of each other, always fighting. Only one wins. But they come in pairs. What will be the pair for less than equal to? Greater than. The pair for greater than equal to will be less than. And the pair for equal to will be? They will always be in pair. And together they form the entire universe. इसके बाहर कोई केस हो ही नहीं सकता, आप बता दीजिए. पेप्सी कुछ और बोल सकती है इन दोनों के अलावा. या तो ये होगा या फिर ये होगा. Either this or that. Either this or that. This is hypothesis, and the ones that are written on the top, these are null hypothesis, also shown as H0. Right? And the other one is alternate hypothesis, also known as H1 or H alpha. Right? This is okay? Are you all okay with this? Now we will go a little deep and we will understand what is happening. Right? In order to understand what is happening, I am drawing 3 normal distribution curves, and you will now tell me if she's saying that the cold drink in their bottle is greater than or equal to 300. You tell me, what will Pepsi be happy with?
100%.
And what would they be? So will they ever care? Will they ever care if it is 310?
No.
350? Even happy? 400? More happy? The chances of them being wrong is getting lower and lower as you are increasing this. The more amount of cold drink in the bottle, the lesser will be the chance of them getting sued in the market. Right? The problem will only arise on the lower side. The problem will only arise on the lower side. So if they are saying that the cold drink is 300, yes or no? What will you say? That okay, 95% confidence interval is, let's say, a number which is ranging from X lower bound to X upper bound. They will never ever have any problem in this region. If the cold drink amount on an average is coming out to be 400, 500 ml also, they will be happy. There is no chance of them getting rejected. उनका क्लेम क्या था कि भैया हम तो 300 से ज्यादा देते हैं. अब 300 से ज्यादा तो 500, 700 इनफाइनाइट. आपके घर पे आपने ली 300 ml की बॉटल टैंकर, आप उनको नहीं करोगे. जितना चीज निकाल के भर लोगे, है ना? कई लोग हैं टैंकर में दूसरी बोतल खोल के मिला देंगे क्या यहाँ पूरा मोहल्ला. Right? You are getting what I am trying to say, right? You will never ever have a problem on the upper side. You will only have a problem if it is lower than a certain amount. Where it is outside our 95% confidence interval. That is why this particular kind of hypothesis and this particular kind of test is known as a lower tail test or lower tail hypothesis. Lower tail. You have only the rejection region in the lower tail. Why am I calling this as rejection region? Because let's say आपने बोला 95% confidence interval से ये आ जाता है 270 से लेकर के 330 या फिर 330 आ जाता है. अब आप बोल रहे हैं अगर मेरे सैंपल में, if my sample mean is lesser than 270, Pepsi is lying. And if it is lesser than 270, I will reject the hypothesis. So the rejection region is only on the lower side. and we call it the rejection region. If you're talking about 95% confidence level, this entire thing will be 5%. Right? Not on both the sides now. Only on one side you have the rejection region. Simply, when Mokobara says that the number of defects should be less than or equal to 2, will they ever worry if it is 0 or 1 or 2 also? So you're saying 2, you will never ever have any problem on the lower side. Jitna kam utna acha. You will only have a problem on the higher side. So this is known as the upper tail test. Upper tail test, where the rejection region is only on the upper side. And let's say if you're talking about 95%, again this will be 5%. This is okay. What about this one, where the car is saying that you will get a notification exactly at 10K. आपने बोला कि ठीक है जी 95% कॉन्फिडेंस इंटरवल बना लेते हैं, आपका सैंपल में इधर उधर हो सकता है, कई बार हम देख लेते हैं कि आपका यहाँ पे आना चाहिए 9.5K to 10.5K. The car should give a signal between this. If the car gives a signal before 9.5K, you will be unhappy. And if the signal comes after 10.5K also, you will be unhappy. Right? So the rejection region is on both the sides. That is why it is known as a two-tail test. Both of them together, they form a single tail test. सिंगल टेल एक ही साइड पे रिजेक्शन रीजन है, टू टेल दोनों. अब अगर आप 95% कॉन्फिडेंस इंटरवल की बात करते हैं, if you are saying that the confidence level is 95%, you are actually talking about 2.5% on this side and 2.5% on this side. Is it okay, my friends? What side is this? Left. Lower tail is also known as left tail test. Upper tail is also known as right tail. Well, two tail is a two tail. Are we good till this point? Are you all okay with this?
Yes.
If you understand this, believe me, hypothesis is just a cakewalk. Just a cakewalk. After this, I'll tell you the rule, the golden rule now. And the golden rule is simple. देखिए जी, एक वैल्यू आएगी इसकी, एक वैल्यू आएगी एक्स लोअर, यहां पर आ रहा था, मान लीजिए एक्स अपर आएगा, यहां पर भी एक एक्स लोअर और एक एक्स अपर आएगा. राइट? yes or no? If this x lower and what will happen, you will find a x bar, you will find an x bar, sample से आएगा. If this x bar is lower than x lower, reject null hypothesis. And again, go back to the previous discussion. You are saying reject null. Why could you say reject null? One counter example outside, gone for a 6. If it remains inside this range, do not reject. Never say accept. Do not reject. Okay? If the x bar value is higher than x upper, reject. If x bar value lower than xl or higher than xu, reject. Now I don't want to use x. X makes me sad. So I will use z. Right? Why do we use z and how and in what sense? So I will use two z values. One z value I'll call as z calculated. And the other z value will be z critical. Wow. See, I know all. Let me know all. I knew it all, but somehow it is hard. I know it all. Z critical. What is this z calculated? This is for your sample, which we are calling it as x bar. ये जो आपने कैलकुलेट किया है अपनी मेहनत से, राइट, जो कि यहाँ आएगा. Z critical क्या है? Z critical is on the basis of the confidence interval. This is from the Z table or critical value or whatever. Right? This is this value Z critical. Here this will become Z critical. Here this will be Z critical and this will be Z critical. Critical means this is a critical value. If you are going beyond the critical value, sorry boss, right? Z critical. How do you calculate this Z critical? Very, very simple. 95% confidence level. I want 95% area to be covered, 5% to be left on this side. I know that this Z critical value here is 1.65. Here also it is 1.65. Here it is negative 1.65. Here it is positive 1.65. Here, because it is getting divided into two parts, I know it is 1.96. Remember previous?
Yes.
Negative 1.96, positive 1.96. This is Z. Known as Z rule of hypothesis. I like another rule. So Z rule is clear. Z critical is beyond. Now, again, books will confuse you. Will confuse you saying, because Z critical is negative. So if Z calculated will also be negative. So if Z calculated is more negative in comparison to Z critical, more negative means minus 2, 3, 4, 5. More negative, you reject. More negative means generally what? Lower. Minus star बड़ा या minus 1 बड़ा?
चार बड़ा है.
Minus 4 is bigger or minus 1 is bigger? Minus 1 is bigger. So the rule will be, if this Z critical is lesser than Z, sorry, if Z calculated is lesser than Z critical, reject. But here it will be opposite. If Z calculated is higher than Z critical, reject. I don't say all that. In my book also I write simple. Mod. Forget the sign. If Z calculated is higher, only the magnitude. Higher, reject. Higher, reject. Higher, reject. Simple?
Yes.
Will you remember this?
Yes.
Now, one more. Last thing which I like more. There are two ways in which you can take the decision. One is on the basis of Z. Other one is on the basis of the p-value. P-value is what I like more. Why? Because when you will be doing a test, let's say you are getting Z here. Your Z calculated is here. You know with Z critical, 95% of confidence level, this and that and all. You know alpha value? 5%. Alpha value here also will be 5%. Right? Alpha value here also will be 5%, but it is getting divided into two parts. So alpha by 2 will be 2.5%. Then with this Z specific, this Z value, associated with this Z value, you'll get a P value. At this particular Z, how much area is covered? Right? At this particular Z, how much area is covered? This will be a P value. Simple. P value less than alpha value. Area covered by this is lesser than 5%. That means your Z is here. So P less than alpha. Reject null. I like this rule. This is universally applicable everywhere.
What is P?
P is the, let's say I am doing it here, okay? Let's say this is your Z calculated. How much area is covered by this? That is P. You go to the table and see P value. Simple rule. P is low and there's a rhyming, scheme also. P is low, null has to go. P is low, null has to go. Repeat. P is low. So if the P value is less than alpha, reject null. Too much to remember, too much we have done, right? Let us very quickly revise this, okay? Very quickly. Then we'll stop.
Type 1, type 2.
Sorry?
Type 1, type 2 errors.
अभी सब अब अगली क्लास में एक क्लास एक्स्ट्रा लेनी पड़ेगी देखते हैं. So there is, what is the hypothesis? I'll very quickly repeat. We have time. Lesser than that. Okay. There are, what is the hypothesis? Any testable statement is a hypothesis. There are two kinds of hypothesis, null and alternate. Null hypothesis is the hypothesis which has an equal to sign. Alternate is the hypothesis which will be exactly opposite of null. Null hypothesis can be lesser than equal to. So alternate will become greater than. Null hypothesis is greater than equal to. Alternate will become less than. Null hypothesis is equal to. Alternate will become not equal to. This will come in pairs only. Now, when you write the hypothesis on the basis of the kind of thing that you have, on the basis of the kind of hypothesis that you have, I'll give you a way to remember also. Don't, once you've written the hypothesis, look at the sign of alternate. Alternate is less than lower tail or left tail. Less, low, left. LLL. Alternate hypothesis is greater than, higher, right, upper. Alternate is not equal to 2T. In a lower tail test, the rejection region is only on the lower side. In a higher or upper tail test or a right tail test, the rejection region is only on the upper side. In this one, you will have rejection region on both these sides. If the D calculated value is beyond Z critical, reject. P less than alpha, reject. D calculated higher than Z critical, reject. P is lesser than alpha, reject. Here also Z value is higher than this, reject. Higher than this, reject. P is less than alpha, reject. Right? Now, what you have written this in your notes. Photograph. If there is anybody who wants to keep taking photo, is very poor in writing, but may I discard this? I am discarding this. I discard this. I very quickly right. So in the next class, what we'll do is we'll do this hypothesis testing on Excel, right? And I'll show you how it is done. So yeah, that's all for this class. Now we'll have a quiz. Surprise with two. On the distributions, what you did in the last class, not in this class. Okay. Now, if you have solved the questions that were given, you will be able to solve it easily. If you have not done it, God save you. No cheating. It will be live on your LMS only, right? So the quiz will be live on your LMS. Small quiz. Should not take a long time. Please attempt all the questions. If you have any doubt, anything, you can always ask.
During the quiz?
Sorry?
During the quiz?
During the quiz also, yes. Yes, you will need Excel.
Excel?
It's a 20-minute quiz. Right. 20 questions. 10 MCQs and 2 subjective. You can use pen and paper to solve, you can use Excel, and you will have to upload your answers for the subjective ones in the quiz. Let them take 25 minutes because of 25 minutes, 5 minutes for uploading and other things.
आया नहीं सर अभी
याद ही नहीं
It is live, you may please start attempting.
उसका सकते हैं ना इसमें
बट आप चेंज कर सकते
Don't use internet. Otherwise, use slides, cheat sheet. If you want to use your notes, do anything, but don't use internet. That's it.
उसका 24 लगता है मल्टीप्लिकेशन
Probability bar है.
प्रोबेबिलिटी बार है
तो ये
Like, hold. Close. You are going.
Wait. No talking, please. It's simple, very simple.
दिल में या फिर हाथ से.
It's good. It equals to its bar. The formula is x minus mu upon sigma. Okay. If you want me to tell you any formula, I'll tell you. No problem. V is x minus mu upon sigma. Don't talk. मेरे से पूछो.
X equal to मतलब
P का मतलब probability at x is equals to 3. Exactly at 3.
Okay.
Probability of having x as 3.
sir P0 P is equal to 0.2 फिर क्या रहता है P निकालो सर ये P तो दिया ही हुआ है 0.2
नहीं वो आपको दिया हुआ है उसके लिए, आपको निकालना है 3 के लिए।
इसके लिए
10 बार कर रहे हैं, यही ना क्वेश्चन।
कैलकुलेट
n is 10,
n is 10 P is equal
p is equals to
0.2
you have to find out the probability of having exactly 3 successes. 3 successes in 10 attempts. Got it?
वो अच्छा हर बार जब करते हो तो probability 0.2 है
Yes, sir. In Excel, Poisson distribution का फॉर्मूला है e raised to the power minus lambda lambda raised to the power x upon e raised to the power minus lambda lambda raised to the power x
ये
upon-
सवाल ना आप भी सॉल्व करना है एक बार हमें समझ आएगा करा कैसे है
अभी कर लेंगे।
हमें तो कुछ नहीं समझ आ रहा
एक्सेल यूज करो दोस्त, पॉइजन के लिए एक्सेल यूज करो। इज इक्वल्स टू poisson.dist। एक्सेल यूज करो, बायनोमियल का क्वेश्चन भी एक्सेल से करो, हो जाएगा।
आ गया उसमें
बायनोमियल का फॉर्मूला
अगर मैं क्लास में नहीं आता
मैं नहीं मदद करता।
अगर मैं कोशिश
जो आदमी आया नहीं उसका मैं हूं नहीं।
अरे कोशिश करी थी क्लास देखने की
चलो हम फॉर्मूला बता देते हैं। बायनोमियल डिस्ट्रीब्यूशन का फॉर्मूला होता है इज इक्वल्स टू binom.dist एक्सेल में। बाकी एक्सेल खुद बताएगा आपको क्या क्या वैल्यू चाहिए, वो उसमें से डाल दीजिए उठा के। Binomial is binom.dist, poisson is poisson.dist, uniform is uni करके आप ढूंढने का जाएगा। नहीं, नॉर्मल डिस्ट्रीब्यूशन का है, सॉरी norm.dist, यूनिफॉर्म का नहीं मिलेगा। एंड जी वैल्यू निकालने के लिए द फॉर्मूला इन एक्सेल इज स्टैंडर्डाइज। ना ऐसे नहीं, अपना क्लास के बाद ये सब मैं मदद करूंगा भाई।
सर नंबर अंडरस्कोर इसका क्या मतलब
नंबर ऑफ सक्सेसेस जो आप पूछ रहे हैं।
अरे 10
क्युमुलेटिव का मतलब है एग्जैक्टली 3 या फिर नहीं ट्रू मतलब क्युमुलेटिव है, मतलब
Exactly बोला।
इफ इट इज लेस देन इक्वल टू, अगर एग्जैक्टली एक पॉइंट बोला तो
बस इतना करना था
यस सर।
दिया हुआ 35 आजकल कौन से 28 तो 1.4 अच्छा वैसे ओ लाइक दैट कैसे किया तुमने ये एक्सेल में निकलेगा वो टेबल क्या बता आज सर लिख रहे थे आज भी हुआ आज डिटेल फॉर्मूला लगा के गलत आ रहा है कोई पूछना फॉर्मूला
सही है
पॉइंट बोलो ना भाई 1124 आ रहा है
नहीं ये मेरा अब ग्लिच हो रहा है
If you are not getting exactly the same answer in the options, put the closest one, okay? You'll have this problem in 2 questions. You'll have this in 2 questions.
Receiving at most.
Somebody was asking something. Closest जो आ रहा है वो डाल.
पास नहीं है
Closest डाल दो ना, closest डाल दो. 0.17, 0.19 बहुत ज़्यादा दूर थोड़ी ना होता है यार. क्या कर रहे हो तुम? बच्चे थोड़ी ना हो यार. कौन?
कौन सा क्वेश्चन है
Closest डालो, closest. Do it fast.
समझना भी तो पड़ता
एक्सेल में जो होगा equal to poison dot distance by login dot result मेरा भी मैच
पोस्ट करना 41.0 बात
और किसी में तो नहीं आ रहा इसी क्वेश्चन था बाकी तो एग्जैक्ट आ रहा है
हो गया भाई अप्रोक्सीमेशन था वो पॉइजन वाले में था
हाँ?
इसका आंसर पॉइजन वाला
1.17
एक बायस सोर्स
अरे
एवरेज रेट का मतलब मीन
पता नहीं.
9.5 दो क्वेश्चन
क्या होता है यही वाला तो दोनों ने खोल रखा है.
9th पे
So now those of you who have not written both the quizzes, this one and the previous one, उनका एक quiz का marks गया. There'll be one more quiz. We'll take 2 best out of 3, no?
फिलहाल तो पहली क्लास में हो गया था
फिर उसके अपने रिजल्ट नहीं किया
रिजल्ट आ तो गया था उसका तो दिन.
नहीं
रिजल्ट वाला एंड में दे देंगे
अच्छा लास्ट में दे देंगे.
इसमें सर एक्सेल या फिर नोट पैड पे जो भी वर्कआउट करे दैट वी हैव टू अपलोड
For the last question, upload the screenshot of your Excel with the formula click. If you're doing it on Excel, if you're doing it by hand, you just need to put the entire thing. If you are, but make sure if you are solving it on Excel, please click so that I can see the formula also.
sources
Last 2 questions are subjective. More than one is also possible.
24 inch
More than one is possible. There are questions where there are more than one option correct also. I'll tell you there are 2 questions where one question is on discrete distribution and there's one question on bias. In these 2 questions there are multiple options correct.
लेकिन सिलेक्ट तो एक ही करने दे रहे हो
एक ही सेलेक्ट करने दे रहा है.
ऑल ऑफ द वन है उसमें
अच्छा ऑल ऑफ द अबव भी हो सकता है ऑप्शन पता नहीं मेरे को.
सर यार
बहुत सीधे लोग हैं हम लोग आंसर ही बता देते हैं. चलो
कौन सी कन्वीनियंस
प्लीज लेट मी नो व्हाट सबमिट.
सोर्स नॉन रिस्पॉन्स
Oi,
सर आपने जो बताया था वही बता रहा हूँ और इज इक्वल टू
प्लस माइनस 2SD।
इतने बड़े होने के बाद ना ये सब हुआ नहीं।
सर बड़े होने
मजा आता है अलग वाला भाई, ये वाला नहीं, बच्चों वाला। करो करो।
9395। Sir, receiver everyone. क्यों उसमें
ये वन में होता है
कोई आइडिया
95
शर्मी। पहले मैंने तो 95 ही किया, आगे बढ़ गया। मेरे को सारे लिखे मार्केटिंग इन द टोटल। क्वेश्चन में जैसे प्रॉब्लम
बोल जाएगा ना प्रो लेफ्ट हाँ फॉल्स
बात करेगा ना उसको माता रानी पाप देगी।
ये जानने का मार्शल सीधा मैं कह रहा हूँ मैं जेल
अरे शर्म करो।
किसने स्क्रीनशॉट एक्सेल ला
स्क्रीनशॉट डालो इसको सेलेक्ट करके।
6 per day।
हाँ ये भी कर सकते हो, यू कैन पुट द स्क्रीन स्क्रीनशॉट ओनली। भाई डोंट अपलोड द एंटायर एक्सेल एंड ऑल फॉर मी, ओके?
APG डाल दो प्रेफरेबली।
हाँ दैट विल बी बेटर। स्क्रीनशॉट लेके जेपीईजी सेव करके डाल दो। अरे भाई डाल
वैसे फॉर्मेट बोला था उसने पूछा
At least 4 probably.
तो क्या अपलोड ही करना है, पेस्ट नहीं?
तो सेव स्क्रीनशॉट सेव करना है मुश्किल।
बनाया था।
दिखा
तो तीनों डाल दी ना।
आपको जो पड़ा
क्यूमुलेटिव
तक क्या लो स्क्रीनशॉट
ये कहाँ होता है? ये पेस्ट ही करा है हर बार। इधर
एक्सेल अपलोड कर दें?
नहीं तो समझाया नहीं।
पेज कहाँ करूँ, कैसे करूँ? ये नहीं मैंने कभी।
पिक टूल
होता है
बॉडी असीम
थोड़ा अपलोड कर।
स्निपिंग टूल है। स्निपिंग टूल
तो है
तो कर लिया। इमेजेस में आता है
उसमें सेव नहीं होता डायरेक्ट।
इसी में सपोर्ट और
तो है कमांड शुड फोर स्क्रीनशॉट है ना, मतलब विंडोज भी तो ओपन करना पड़ता है पिक टूल से मिला
Please submit 4 minutes.
नहीं समझ आ रहा।
या मैं ना सेटिंग्स में देखती हूँ।
यार क्या डेटा होता है कोर्स and postal. Please submit, please submit.
एग्जाम भी हो गया सर लास्ट में सर कोई एग्जाम भी है क्या लास्ट में कोई एग्जाम है क्या लास्ट में
लास्ट में
एग्जाम रहता है क्या कोई?
एग्जाम है ना एग्जाम एग्जाम से गुड बहुत अच्छा इज इट डिफिकल्ट
मतलब अच्छा कौन सा होता है
नॉट डिफिकल्ट if you could submit कर दिया सबने
हाँ जी.
if you could relate and if you felt that the questions are not alien obviously if you've not attended the class it might look little alien
आपने एक बार बताया सेकंड बार हो गया
but otherwise if you could understand the question if you could understand that okay ये तो हुई थी बात मैंने ही practice नहीं करी है तो this is a wake up call practice otherwise I think it was fair